sklearn, cluster, clusteropticsxi. Description. This function calculates the reachability plot based on the optics algorithm and returns the xi values for each data point. The reachability plot is a graphical representation of the density-based clustering structure of a data set. Xi values are calculated for each data point, representing the estimated density of the region surrounding the data point. Inputs. X. This is the input data, represented as a 2D array with each row corresponding to a data point and each column corresponding to a feature. Min-samples. This parameter defines the minimum number of data points required for a cluster to be considered valid. This parameter is essential for controlling the sensitivity of the optics algorithm to noise and outliers. Metric. This parameter defines the distance metric used to measure the similarity between data points. Common metrics include Euclidean distance, Manhattan distance, and cosine similarity. Cluster method. This parameter defines the method used to identify clusters within a reachability plot. Outputs. Xi. This is a 1D array containing the xi values for each data point. Steps. The function calculates the reachability distance matrix for the input data X using the min-samples parameter. This matrix represents the reachability distance between each pair of data points. The optics algorithm is then applied to the reachability distance matrix, producing a reachability plot. This plot visualizes the clustering structure of the data. The xi value for each data point is calculated as the local maxima in the reachability plot. The xi values provide an estimate of the density of the region surrounding each data point. Metrics. Xi. This metric represents the estimated density of the region surrounding each data point, providing insights into the clustering structure. Visualization plots. Reachability plot. This plot is a key output of the optics algorithm. It visualizes the clustering structure of the data by plotting the reachability distance of each data point against its ordering in the cluster hierarchy. Fine-tune parameters. Min-samples. This parameter controls the sensitivity of the optics algorithm to noise and outliers. A higher value leads to fewer clusters and a greater tolerance for noise, while a lower value leads to more clusters and greater sensitivity to noise. Metric. The choice of metric affects the distance calculations between data points, influencing the resulting cluster structure. Uncertainty methods. Xi. The xi value for each data point provides an estimate of the density of the region surrounding that data point. This value can be used to assess the uncertainty in the cluster membership of each data point. Challenges and fixes. Challenge 1. Identifying the optimal min-samples parameter can be challenging. Setting a value too low can lead to overfitting, while setting it too high can lead to underfitting. Sample use case that resulted in challenge 1. If the dataset contains many noisy data points, a low value for min-samples might lead to many small clusters, including those containing only noise. Fixes to challenge 1. Experiment with different values of min-samples based on the characteristics of the dataset and the desired level of detail. Visualize the reachability plot for different values of min-samples to assess the resulting cluster structure and identify an optimal value. Challenge 2. The choice of metric can significantly impact the clustering results. Using an inappropriate metric can lead to inaccurate clusters and misleading interpretations. Sample use case that resulted in challenge 2. If the data is highly dimensional, using Euclidean distance as the metric might not be optimal, leading to clusters that are not well defined. Fixes to challenge 2. Consider the characteristics of the data and choose a metric that reflects the underlying distance relationships between data points. Experiment with different metrics and compare the resulting clusters to determine the most suitable choice.